Okay. So on the tangent stuff, I want to start with the idea of looking at a circle. Okay. So if you could, in your notes, just take a sketch of this circle. This is not a unit circle. This point, in fact, is 13, 0. Does anybody want to hazard a guess as to the equation of this circle? Center is at the origin, and that point is on the x-axis there. What might the equation of this guy be from Algebra 2? Anybody? It's centered at the origin, so h and k are both 0. X squared plus y squared equals? Well, what is r? Okay, so what is 13 squared? 169. Okay, so this is the equation of this circle, right? 13 squared is 169. So far, so good? Yay, verily? Okay, now let's consider various points on this circle. In particular, I want to consider this point right here, which has coordinates 12, 5. I want to consider this point right here, which has coordinates 5, 12. This point up at the top, which has coordinates 0, 13. And there's another point that's like 45 degrees out right here, and it has coordinates 1, let's see, 13 over the square root of 2. 13 over the square root of 2. Okay, so before we jump into the trig world, if I ask you to verify that this point really lies on that circle, how would you do that? How do you do that algebraically? Tell me, show me that you know that 12, 5 lies on the circle. How would you do it? Okay, so in here for x, you would plug in 12. So that would be 12 quantity squared, yeah? And then likewise for the y, right? Y is 5 plus 5 quantity squared. And the task is, does that really equal 169? If it does, then the point's on the circle. If it doesn't, then the point's not on the circle, right? That's what we mean by a point satisfying an equation. So sure enough, 144 plus 25 does equal 169. That's a check. So that point does lie on the circle. So far, so good? Okay. Now, the one that was sort of weird was that one that had 13 over the square root of 2 for x and y. How would you verify that one's on the circle? Well, this is not rocket science. We know how to do this one. How do you verify that one's on the circle? Substitute them in for x and y, right? Okay, so we'd have to take the square root, 13 over the square root of 2, and we'd have to square that. 13 over the square root of 2, we'd have to square that. That's the x, right? And we'll do the same thing with the y. 13 over the square root of 2 squared, and that's supposed to be question mark 169. If that's true, then the point's on the circle, right? If it's not true, then the point's not on the circle. Well, let's see. 13 over the square root of 2 squared. 13 squared is 169, and the square root of 2 squared is 2, right? And then this is the same thing, 169 over 2. Is that equal to 169? Well, you can do the arithmetic if you want. They both have a common denominator. You can add them up. So what's that? 8 carry 1 is 3, carry 1 is 3 over 2. Does that equal 169? Well, it does. Okay, 338. 338 divided by 2. Sure enough, 169. Okay? And by the by, since we're doing algebra here, let me just throw one other thing at you. Does the point, and let me just pick some reasonable numbers. Let's say we had 10 and, I don't know, 10 and 7 lie on the circle. Question mark. Okay, so you know how to determine whether it lies on the circle. By the way, it doesn't. Is it inside the circle or outside the circle? Ooh. What happens if you put 10 and 7 in here? What do you get? You get 100, right? Plus 49, right? 7 times 7? 49. 49. And that's not equal to 169, right? That's 149, which is not equal to 169. So now my question is that point inside or outside the circle? And how could you tell? Well, take a guess. Why would you say inside? It's smaller than 169. You're correct. So that point, 10, 7, might be something like here. 10, 7. Okay, inside the circle, because the sum is less than the radius. Yeah? If we had 10, 9, say I change that to a 9, so now you've got 100 plus 81. Well, that's not equal to 169 either. 10, 9 might be up here somewhere. Let's say right there. Okay? And so that would be, what's that, 181, which is larger than 169. So that means we're larger than that radius squared. We'd be on the exterior side of the circle. Yeah? So this is a rehash of algebra 2. You're supposed to know conics. If I said, give me an expression that ties together all the points inside the circle, how would you do that? X squared plus y squared, everything inside the circle, less than, which is 169. All the points where you square the x and the y and you add them up and you get less than 169, that's the inside. Suppose I wanted to include the boundary, less than or equal to, because now you can actually have the points on the circle. Okay? Does this seem reasonably content? Okay, because you're supposed to know circles. Okay. I mean, if you know all this stuff, great. You can sit there and fold your arms and not write anything down. If you don't know this stuff, I would be writing it down, because I'm going to suspect that if I spend class time on it, it's going to be on the test on Friday. Okay, now let's do trig. There's an angle here. Okay, so tell me the cosine and the sine and the tangent of that angle. Today we're going to be focusing on tangents. Cosine, anybody raise your hand? Cosine. Say again? It's not 12. It's easy peasy. I mean, we know that. Let's just look at y is equal to the cosine function, cosine of any angle. We're in radians here, zoom 7. Cosines never get bigger than 1. The cosine of an angle cannot be 12. That's just wrong. Cosines are always stuck between 1 and negative 1. So somebody else give me the cosine of that angle. It's not 12. 12 13ths, right? There we go. 12 over 13. Remember, it was x divided by r, right? Definition of the cosine was the x-coordinate divided by the radius. If we're on the unit circle, the radius is, on the unit circle, the radius is 1. So you could just say x divided by 1, or simply cosine of theta is x. But that implies unit circle, right? This is obviously not a unit circle. This is a circle of radius 13. Okay, sine of theta. 5/13, right? Y divided by x. Yes, 5 over 13. Or sorry, y divided by r. Sine is y divided by r. And the tangent is y divided by x. 5 over 12. So far, so good? Okay. So yeah, you have to know the basic definitions of the trig functions for any point in the plane. This particular point is not on the unit circle, this ordered pair, 12, 5. Yeah, it is defining an angle, and you can talk about sines, cosines, tangents. And obviously the reciprocals, you know, the secant, if you wanted that, would be 13 over 12, and so forth. Okay? Anybody have any comments or questions at that point? Okay. Let's look at what happens as that angle gets bigger and bigger and bigger. Okay? So if we're here at this 45-degree angle, and maybe I can take away that line and put that line. This is a 45-degree angle, or if you want, pi over 4. And the ordered pair again was 13 over root 2, comma 13 over root 2. And if I said, what is the tangent? I mean, we're focusing on tangents now. Tangent of that angle theta, what would you say? 13 over root 2 divided by 13 over root 2, which is? Can't hear you. 1, sure. The tangent of 45 degrees is 1. You should know that, right? Because remember this line that goes through the origin, this is the line where y equals x. Any point on that line, the x and y coordinates are the same. And when you're doing tangents, the tangents of an angle are always going to be the y coordinate over the x coordinate. And if these two are the same, that gives you 1, right? Okay, so that's equal to 1. But now watch what happens as we get closer and closer to the top of the circle. And in particular, I want to think what happens when we get up to this point 5 over 12, or 512. Okay, so now we've got a larger angle, theta, and what's the tangent of that angle? 12 over 5, right, which is 2.4. Okay? Now, if I said, somebody give me a guesstimate, how many degrees is this? Could you give me a reasonable number? About how many? 60 degrees? It actually looks much more than 60. Say again? 75, 80 maybe? Okay. 60 degrees, we know if I asked for, again, let's just draw a unit circle real quick. If I threw a 60-degree angle in there and said, what is the ordered pair that matches there? That's a point you should know. That was on one of your unit circle quizzes. What's the ordered pair that matches at 60 degrees? Either x or y is a half. Which one is it? X a half or y a half? X is a half, so we're halfway over. That doesn't, yeah, I guess it is. My diagram is lousy. Let me do a better circle. Okay, so here's 60. And x is a half, right? And y is square root of 3 over 2. And if I said, what is the tangent of 60 degrees, right here, 60 degrees, you would say? Square root of 3, right? Because it would be y over x, so it would be the square root of 3 over 2 divided by 1 over 2, and the 2's cancel, so you get square root of 3. And square root of 3, if I just jump on my calculator here for a minute, square root of 3 is about 1, oops, clear. Square root of 3 is about 1.7, right, 1.7. And here we said this tangent was 2.4. So it's definitely not 60 degrees. And somebody said 75 or 80. Those are reasonable numbers. In fact, if I go to my calculator, and just because we're talking degrees, let me put it in degree mode just for a minute. And I said, what is the tangent of 75 degrees? It comes back to 3.7. So 75 might be a little bit too big. Maybe tangent of 70 degrees might be closer to what we're working with. Okay. Now, as we get closer and closer to the top of this circle, so now consider a point right here, really close to the top. In fact, let me just draw a new circle here. So we have this circle, the radius is 13 again, and I've picked a point very, very close to the top. This y coordinate now, or this point on the y axis is 0, 13. And I'm going to claim that this point has an x coordinate of 1. Question, is the y coordinate 13? Okay, so you're shaking your head. Why not? I mean, you're right, but why would you say that? Or what might the y coordinate be if we're up near the top of the circle here? Okay, x coordinate's 1, so what's the y coordinate? That's the task. Okay, so let me do some work with you. You know the equation of the circle, right? The equation of the circle was x squared plus y squared is 169. I want you to find out what y is. Go ahead and solve for y. I'm telling you x is 1. Solve for y. Use your calculator. Get an approximation for how high this guy is. It's really close to 13, but it's not 13. So how big is it? Let's see, 168 would be 84, which is 42. So 2 square roots of 21. Is that what we're getting? Something like that. What number? 12.96. Okay. So about 12.96. This is an approximation. 12.96. The exact answer, of course, is the square root of 168. Right. That's the number that's there. So square root of 168, 12.961481. Yeah? Anybody unable to get that? Okay, so hopefully you know how to solve for y in that equation. By the by, when you took the root, technically you got y is equal to plus or minus the square root of 168. And this one's obviously positive. Where's the negative one? Where would that point correspond? Okay, bottom. What do you mean bottom? Where could you put a dot on the circle that would be corresponding to what this is talking about? Okay, where would it be? Okay, straight down, right? So if we go straight down, here's a dot where x is still 1, right? All the points in this vertical line are x is 1. So that's x is 1, but now y would be minus the square root of 168, right? Okay. Now, let's look at the angle. From what we've done so far, what is the tangent of this angle? 12.96, okay, thereabouts, right? So the tangent of that angle is going to be y over x, which is about, well, it's exactly the square root of 168, but it's about 12.96. Correctamundo? Okay, because it's y divided by x. Now, as we get closer and closer to the top of the circle, we can still calculate the tangent. But if I say, let's go all the way to the top of the circle. Let's consider what happens if we go straight up. So now the theta is exactly 90 degrees. So theta is 90 degrees, or pi over 2. And I said, what's the tangent of theta? You would say, what? It's not 13. What's the tangent of 90 degrees? Okay, so we're really not awake yet. I know it's Monday morning. Say again? Not definite? It's not 0. It's undefined. Okay. The tangent of theta is undefined, not definite. Did you mean indefinite? You meant not defined is what you meant. Because you're supposed to do y over x. 13 over 0 doesn't make any sense, right? That's a meaningless expression in all of mathematics. Doesn't matter whether you're in this class or calculus or algebra 1 or 4th grade. You cannot divide 13 by 0. And in fact, if we jumped on that calculator and we said, "What, Mr. Calculator, what is the tangent of 90 degrees?" It says, no, you can't do that, right? It's not in the domain of the function. Okay, but if we get close to the top of the circle, we can make the tangent as large as we want. So we're just going to do one more dot just for kicks and jiggles, and then we'll look at the graph. So let's suppose we have, again, we have this circle. This is 13, 0, so the radius is 13. And we have this dot really, really close to the top of the circle. And the x-coordinate now is going to be, I don't know, 1 fourth. What is the corresponding y coordinate? Go ahead and calculate it. Calculate the corresponding y coordinate, and then tell me what the tangent of this angle is, because that's what we're sort of focusing on, is the tangent of this angle. Now, this is not a 90-degree angle, but it's really close. What is the tangent of theta? Okay, to do that, you need the y coordinate. So what's that? Geez, I don't know the decimal. So 168 and 15/16, right? Because you would square a quarter, which is a 16th. Take it away. So it's 150. I hate mixed numbers, but this is what I'm thinking. 168 and 15/16, the square root of that. Yeah? So could you give me a decimal for that? What does it work out to be about? Say it again? No, it's not 12.99, so that's not right. Because we need the tangent. I'm sorry. Yes, that is the correct decimal for this, but remember what the tangent is. The tangent of the angle is the y coordinate divided by the x coordinate, right? So it's that thing divided by a quarter. So what's the tangent now? 51, okay, 0.96 and some change. Okay, so this is about 51.96 and some change, right, according to Maddie. Okay. Do I need to go through any of that arithmetic with anybody? So speak now or forever hold your peace. Okay, yeah, so the y coordinate here is the square root of that number, 168 and 15/16, which is sort of a goofy way of doing. I don't like mixed numbers, but that's what it would be. Okay, now, let's just go to the calculator. As this angle gets larger and larger and larger, I can make this tangent be as big as I want. So here's the tangent. Now, again, I am in degree mode, so let's be clear here. We're talking degrees, not radians. We'll go to radians in just a minute, but let's start with degrees. The tangent of 89 degrees is 57. The tangent of 89.5 degrees, yes, you can use a half a degree, or if you want, you can use 30 minutes. We don't really use minutes in this class. That's 114, okay? The tangent of 89.8 degrees, the tangent of 89.8 is 286. So as we get closer and closer to 90 degrees, right, we can make this tangent as large as we want. Suppose I had the tangent of 89.99952. Okay, so this is really, really, really close to 90 degrees, and the tangent happens to be 119,000, right? Now, I hope you see what's happening here. As we get closer and closer to 90 degrees, this tangent goes to infinity. I can make it as large as I want. I want to make it 100 billion, I can do that. Just make this angle really, really close to 90. Right? So if I said, what's the tangent of 89.999999999, right? And it says, wow, 5.7. What's this E12 mean? 10 to the 12th, right? So I'd have to move the decimal point 12 places. Yes? Okay. However, if I try tangent of 90, I can't do it, right? So the tangent of 90 is undefined. You can't do it. So don't say it's not definite, because that's not the word. And don't write this either. I mean, if you wrote this down, this is sort of a bogus statement. If you said the tangent of 90 degrees equals 1 over 0 or 13 over 0 or anything over 0, this is no. You can't do that. The equal sign is reserved for numbers, and this is not a number. So if I had complete this statement, right, what you should write are the words is undefined. Now, I started this whole discussion with this circle that's got a radius of 13, just to get you out of the mindset of unit circle. In point of fact, all of this discussion is exactly the same if we had a unit circle. So if I had a unit circle This is now our good old 1, 0, and 0, 1, right? And if I had a point, you know, here's a point that I claim is on this circle. This is the ordered pair 3/4, sorry, 3/5, 3/5, 4/5. And then I might ask you, could you verify that that point is on the unit circle? Do that. You're going to take that 3/5, 4/5 satisfies equation of circle. Okay, and you should get the profound statement that 1 equals 1. Does it? I trust? Yeah, okay, so 9/25 plus 16/25 is 25/25, which is equal to 1. Okay, so that point's on the circle. And if I said, you know, what is the tangent of this, right? The tangent of this angle, tangent of theta, you can do that pretty easily just by looking at the y and x coordinates, and you get 4/3, right? 4/3. As the point goes closer and closer to the top, the tangent will get larger and larger and larger. So if I had a point right here that happened to be 1/100th, and I said, what is the corresponding y coordinate? You could find that, right? I would hope. You would square this and get 1/10,000 plus y squared is 1. So y would be plus or minus the square root of, what's that, 9,999/10,000. If you do the subtraction and then take the square root, right? Okay. So, I mean, if I said, what is that number? 9,999. Okay. So, the tangent is going to be that thing divided by this thing, right? So you'd have to take that and divide it by 1/100th, 0.01, and now the tangent's almost 100. Okay, so I can make the tangent go as large as possible. Okay, so here's the graph that you're going to have to know. This set is section 6.5, graphs of the function is the tangent of theta. Okay, so here's my theta axis. You can think of this as an angle. Here's my tangent of theta axis. And let me start with degrees. If this is 90 degrees, we found that as the angle got closer and closer to 90, the tangent went up and up and up and up and up and up and up, right? And in fact, at 90 degrees, the tangent was undefined, but it went to infinity and beyond if you're Buzz Lightyear. We don't like to think graphs in terms of degrees. So instead of 90, can we turn this into radians? 90 degrees is how many radians? Pi/2. Okay? So sure enough, now we're thinking radians. And let me turn my calculator back into radians. And if I said, Mr. Calculator, what is the tangent of pi/2? Because now we're in radians. It will say, no, sorry, you can't do that. Right? You cannot take, says syntax, what's the problem? Oh, how about pi? Pi/2. Okay, can't do it. Pi/2 is not in the domain of this function. There's not a calculation there. However, if I did this, what is the tangent of pi/2 take away 0.000001? So now this is a little bit less than pi/2, right? What would you suspect the tangent value would be? Big, small, positive, negative? Okay, big, positive or negative? Positive, right? Because what we're doing is we're thinking this is the point pi/2, and I'm going just a little little tiny bit to the left of it, right? Because I'm taking away just that little tiny bit. And sure enough, the tangent works out to be, geez, what's that, 1 million? Okay? Really, really large. So here's the first part of the graph that you're going to have to sort of internalize. If this is the theta axis, this is in radians, and here's pi over 2, there is a vertical asymptote here, and the tangent graph will start from the origin and go to infinity, like that. It never hits that vertical line. There's some very specific notation your textbook uses. It's called a limit, and it says as theta goes to pi over 2, and then they have this little minus sign up in the air. It's like hovering, right? The tangent of theta is going to infinity. It gets really, really large. The tangent just goes big. Now, this, again, let me give you a reference in your book. If you've got your book, it's 284, I think. I'll run off too. Here. Okay, so 5, 4. Yeah, so look at your book on 424. It has this notation. So page 424 and 425. This is called one-sided limits. And again, what's happening here, when you see theta going towards pi over 2 with a minus sign, that means the angle is getting close to pi over 2 coming in from the left. So we're coming in from sort of like the negative direction. We're coming in from the left. This little superscript minus you can think of from the left, or you might want to think of it as from smaller theta values. Okay, so we're getting close to pi over 2 from smaller theta values. Certainly the calculator here, that's a pretty close to pi over 2, but a little bit tinier. Okay, now, I guess I should show you an entire period of this tangent function. There's another vertical asymptote right here at negative pi over 2, and the graph does this. Let me draw in the asymptote first. And the graph goes down. Okay. So maybe I can show this on the calculator first of all. I'm going to need a theta number that's a little bit bigger than this. So let's see. On my calculator, I've got the tangent of negative pi over 2, but I need something a little bit bigger than that. So how could I go to the right side of negative pi over 2? Should I add something or take something away? Yeah, I should add just a little bit, right? Just add a smidgen. So let me just add, I don't know, 1/10. Okay? And here's the tangent. It works out to be negative 9.9. Okay? If I get a little bit closer to negative pi over 2, let's see. So instead of adding 1/10, let me add just a little tiny bit. Right? So maybe 1/100th. I'm just going to go to the right just a little bit. I mean, you know, if the pi over 2 bothers you, suppose you just had a number line and this is 7, negative 7, and I want some number a little bit to the right of negative 7. That might be negative 7 plus a quarter. Right? Doesn't it go to the right just a little bit? Okay. So let's go to the right, this time just maybe 0.01. And now the tangent's negative 99. This fact is true. This tangent graph goes down to negative infinity. Now again, when you study this, study your notes or read the text and supplement your notes with what you read in the text. You'll see this statement. The limit as theta goes to negative pi over 2, so we're going towards negative pi over 2, but this time we're coming in from the right side, so there's a little superscript plus. The tangent of theta goes to negative infinity. Now, it looks like a lot of stuff going on here, right? So we're talking about this tangent function. What is it doing? What's the limiting value? Again, look at your text. As theta gets close to negative pi over 2 from the right side, goes down to negative infinity. Okay? Now, I want to get a new picture. I'll put this back on here again, and then I'll throw in more repetitions of this red curve. Okay, so here's my, now instead of calling the angle theta, let me call it this time t. So this is the tangent of t. Remember, you can name that independent variable anything you want. Sometimes it's x, sometimes it's t, sometimes it's theta, sometimes it's whatever you want it to be. Okay, so here's the vertical line. This is t is equal to pi over 2. And here's another vertical line. And this is t is equal to negative pi over 2. And the graph that we had on the other picture was this. Okay? Now, this is actually going to be a periodic function. So if I copy that and paste it, I'm going to get another version of this right here. Okay? So that's exactly the same shape, exactly the same size. Anybody want to take a guess as to what this vertical line here is? Say again? It's not 2 pi. It is, why did you say that? That's correct. It is 3 pi over 2. Now, how'd you get that? (270°) if you're thinking unit circle, right? So here's our circle. I think what Joey's trying to claim is that when we went to this way at 90°, we were undefined, right? Because the ordered pair was 0, 1. And you said 270°. Where would that be on the circle? On the bottom over here. So that would be 270°, right? The ordered pair is 0, negative 1. So tangents again undefined there. But since we're in radians, this is going to be 3 pi over 2. Okay, so that's correct. And if I were to go to the left, again, let me paste this guy one more time. If I put it right here, I have another repetition, and there is another vertical asymptote here. Anybody want to give me a shot what that would be? T is equal to what number? Negative 3 pi over 2. Okay. By the way, anybody want to take a shot what the period is? How long does it take for this thing to repeat? It's not pi over 2. Pi, half a rotation, right? So this distance from here to here is pi, right? This distance from here to here is pi. That's a half a rotation. If you think of your unit circle, it sort of makes sense. We know that the tangent will be undefined at the top and at the bottom. And those are always going to be 1/2 rotation away from each other, right? So this was at pi over 2. If we move that dot down here, that's 3 pi over 2. If we move it back up again, there's going to be another vertical asymptote at 5 pi over 2, right? And another one after that at 7 pi over 2, right? Every pi after that. Okay. Now, let's sort of focus on this guy just for a minute and get some more of this limit notation, because that's sort of the new thing in this particular section. We said the limit of the tangent, now I'm going to be using t because my axis is t. This is not theta, this is the t-axis. The limit of the tangent of t as t approaches pi over 2 from the left, we said that was really, really big, right? So that's what we said before. When you get close to this pi over 2 coming in from the left side, this tangent graph was going up. Okay, suppose you get close to pi over 2 from the right side. So now we're coming in this way. So let's see. Now I want to do the limit of the tangent of t as t approaches pi over 2. We're still getting close to this asymptote right here. Okay, but now we're coming in this way. So we're coming in from the right side. Anybody want to take a shot what we'll put on the other side of that equal sign? What's happening to this graph? Negative infinity. Okay, it's going to decrease, right, without bound. It just keeps going more and more negative. Okay, so sure enough, these little superscripts, whether it's a superscript negative, that means from the left, and this means from the right, okay, that will tell you the limiting behavior as you get close to that particular value. Okay, now it's time to go to the calculator. I'm going to go make sure I'm back in radian mode, and I'm just going to graph, if you can graph this with me, what is the tangent of x? Now, because we're in function mode, the independent variable is always called x. You can think angle if you want. You can think theta. You can think t. You can think whatever you want. But on the calculator, this is called the x-axis. This is called the y-axis, and we're graphing y as the tangent of x. And here's the picture. Zoom 7 is my trig window, and I get all of these little disconnected curvy things, right? All the disconnected curvy things. The vertical asymptote here is not shown. The vertical asymptote is at that tick mark, and that first tick mark is going to be what? Pi over 2, right? So when you do this on paper, you should throw in a dashed line, and you should say x is pi over 2. Right? And then the next piece goes like this, and there's another vertical line, and you should write down whatever the variable is. If it's x, say x equals 3 pi over 2. Okay? And likewise off here to the left, you want to get really comfortable graphing this tangent function, negative pi over 2, right? And then there's another piece that comes in like this. Okay? And that's negative 3 pi over 2. Sorry. We need the asymptote. X is negative 3 pi over 2. Okay. Now, what else do we care about? For functions, we really care about zeros. Right? So we want to know these zeros. And the origin is obviously x is 0 right there. What's the 0 here? X is pi, right? Halfway between half a pi and 3/4 and 3/2 pi, that's pi. And over here, negative pi. Okay, so we know those. And by the way, that sort of makes sense too if you go back to your unit circle. Where is the tangent equal to 0? And the tangent would be equal to 0 here and here, right? This is the ordered pair 1, 0. And this is the ordered pair negative 1, 0. And if we're talking about the tangent of that angle, right, it's y over x. So the tangent of 0 would be 0 over 1, which is 0. There we are. That's pi, tangent of pi. Tangent of pi is going to be 0 over negative 1, which is this guy right here. Okay, that's the tangent of pi. Okie dokie. What else do we need? Oh, one other thought about this variable. If we're on the unit circle, now let's go back to, because we do have a test coming up on Friday, so we're going to have to go back to something in 6.1, arc length. Okay, so this is a unit circle, which means this is the ordered pair 1, 0. This distance is exactly 1 unit. The radius of the circle is 1. It's a unit circle. If I were to take that same distance and run it along the circumference, So if I had a piece of thread, it would be easy. Imagine a piece of thread going from here to here and running along here. So this is also 1 unit. Okay? What is the measure of this angle? So now it's that question. You can give it to me in radians. What's the measure of that angle? Here's your equation. S is equal to r theta. I'm telling you what the arc length is. The arc length is 1. The radius is 1. What's the angle? In radians. It should be obvious, right? 1. Yeah. The arc length is 1. That's this. The radius is 1. That's this. So theta is 1. Right? So this is 1 radian. You can think angle. You can think arc length. Or you can just think number. All of those are good thoughts when you're talking about the tangent of theta or the tangent of x. Okay? I'll put some homework up on the web page this morning. Start looking at tangent stuff. See you later. Yo.